Hello everyone and welcome back to our video tutorial about SpotMAX. So in today's video we are going to see how the output files that has been generated by SpotMAX, and we are going to see how to visualize the results in the graphical user interface so that we can judge whether it worked or not, and then we will look into how to fine-tune the the parameters in order to get better results in case it didn't work well. So this video is part 2. I recommend watching part 1 first if you're not familiar with how to run the analysis. That's where we looked into the analysis parameters and running the analysis in order to get to the point where we are now. So now we need to fire up SpotMAX as we did last time. We open up a terminal, we activate the specific conda environment, and we run ACDC. Okay, so now that we have ACDC, we can actually launch SpotMAX. And we are back into the graphical user interface. So in order to visualize the results, before doing that, the first thing you need to do is to check whether the output files were actually generated in the last analysis, which means, and the output files, if we open up the data we analyzed last time, so we can get the data into the file explorer. And we now see, if you remember last time we had the images folder. Now, on top of the images folder, we also have, actually below, we actually have a folder called SpotMAX output. And this is where the output files of the analysis have been generated. And if we look inside, we see some files. So as you remember last time, I was talking about the run number, and the run number is the first number of the files that you see here. 1_1 is the run number 1. If you get number 2, you will get additional files called number 2. At the end of the files, you see tutorial or tutorial aggregated, and if you remember, tutorial was this parameter here, text to append at the end of the output files that you can see here, which, if you remember, we call tutorial. And then we see three different files. So the files, that's three different groups of files. So the first one starts with, after the run number, 0_detected spots. Then we have 1_valid spots. Then we have 2_spot fit. This is about the spots. Then we have a fourth actually group called 3_reference channel features. So the detected spots are all the spots that have been detected, even if they are slightly outside the cell. So there could be some spots that have cell ID 0 actually, and they are not filtered. So if you had some features here, spot channel features and thresholds for filtering through spots, these are not filtered yet. So here you can kind of see all the spots that have been detected. Valid spots are all the valid spots, so if they were lying not on a cell and some of the features did not pass the quality control here, our true positives basically filtering, they are all here, so they will probably gonna be less than the detected spots. And spot fit, if you had additional filtering based on spot fit features, they would appear here. And spot fit, if you remember, is this part here, compute spot size, fit Gaussian peaks. If we activate this, there is a third step after detection of quantification and additional features. And all of these features, it's not the topic of this video. Maybe we will talk about the features in the next video, but they are anyway documented. I will leave a link down in the description. And also how the output files, actually the naming scheme, is also documented there, and we'll put it down, a link into the description. So SpotFit would be additional filtering and also additional features, because SpotFit computes, for example, the diameter, the total integral of the fluorescence intensity under the spots, and all kinds of other stuff. While, for example, 3_reference channel, these are not about spots, these are about the reference channel, and these are the features of the reference channel, the morphology, volume, size, and so forth. And as you remember, I said it many times actually, last time, the analysis parameters, if we open it up, they have been saved into this file here. And the only difference from our master file that you remember, if you remember, is that we can actually go here, we have source parameters file, and it tells us where this file was generated from. So we can actually backtrack, go to this file. In this case, it was a temporary file, so by restarting my machine, it's probably gone. But at least we know this was the source parameters file where these analysis parameters came from. And as I said, you don't have to worry, they always get saved with the specific run number, which in this case is one analysis parameters tutorial. So if we have these files, you might not have all of them. If you don't do any reference channel analysis, you will not have this one. If you don't activate compute spot size, you will not get spot fit, but at least detected and valid spots should be there. If they're not there, there might be an issue with the parameters, there might be actually a bug, so it's probably easier to contact us and we can look into why you don't get these files. Okay, so now we know we have the files, we can load them, and if you want to visualize them, the easiest is to load the image data first, because then we put the spots on top and we see whether it worked or not. So we load our position, and this is the same as with Cell-ACDC. If you have snapshot data, you can actually load and multiple positions. You can actually load multiple positions. By snapshot data, I mean non-time lapse. You can load multiple positions into the GUI so that when you press next on the keyboard, you go to the next position. While if you have time lapse, you need to load only a single position because when you go next, you go to the next frame of the time video basically. So in this case, I have only one position snapshot for this tutorial, so I will load this and I will not get asked to load, and actually I do get asked here compared to ACDC actually, because here SpotMAX has a slightly different dialog at this point where it shows you that have been spot content and also spot size, so the size of the spots has been calculated and the detection has been run, so you get some kind of a summary here of the analysis. So we load this position, we load the spot channel, which if you remember it was MDM1. We select the segmentation of the cells, so we get a contour around the cells. And you can see actually here you could load different type of segmentation. These were not there last time before running the analysis, because these are the masks. As you remember here, we turned on save spot segmentation masks. We also turned on save reference channel segmentation masks. So you will see them also here, because these are not in the SpotMAX output folder here, but they have been added to the images folder exactly here, because these can be loaded as segmentation mask in SCDC, in the contours, in overlay of the segmentation mask. So these are actually instance segmentation labels exactly as the cells, while spot detection is more like a table with the coordinates and the features. So anyway, we load the segmentation of the cells for now. We go through the usual dialogues and we get to this point. So now we are back in business. We are back to where we were last time, if you remember. And this is this cell, so makes sense to see the relationship with the mother and bud cells. But of course, remember, you can change this kind of visualization. You can use the segmentation masks instead of the contours. But I like the contours and I like the annotation of mother and bud, basically. So now we can load the results. So to load the results, we go to the inspect and edit results. And here we press load results from previous analysis, or alternatively, we can use this button here. So we press this button, and now we get this dialog where we basically want to decide which of these spots to load. Usually, if you're just looking into visualization, you probably want to load spot fit. However, if you're looking into check the features of the false positives that have been removed here, they are not here, so you cannot see them here. You would have to load this one, and then you will be able to see also false positives if you have removed them. If you don't set any features for filtering false positives, these will be basically identical because they will have the same number of spots. In our case, I don't remember, we probably did some filtering or not, probably not, so I will load the spot fit, and then we can choose how to annotate them on the images, because you can load as many spots as you want. So for example, you could load spot fit in red circles, then detected in blue triangle. So here you have all the different annotation types, and this actually allows you to see that when they are red, they are what SpotMAX decided were the true positives. When they are only blue, for example, would be those false positives, and you guys can actually get an idea of which one have been removed. In our case, I will load this one. I leave default to circle, symbol color, symbol size, and opacity 0.30. We press OK, and you don't get much of a and it could look like they have not been loaded because they get annotated only in the spot center. So you would have to basically go through, and you can see they start appearing here. This one has been detected, and this one here has been detected, and these only in the center of the spot. As you can see, it looks pretty good. This is Z-slice data. If you have 2D data, you would see all of them in one shot. One easier way to see is to do a max Z projection in this corner here. Actually, I realize now that you don't see this one because there's my face there. So here, max Z projection, which was actually behind my face, press max Z projection, and you can see we get the detection of the spots here. Looks pretty good to me. They have been detected as we discussed. If we had to detect these as well, then you would have to choose a different threshold method. That was in the previous video, so I recommend watching that first. But here we see whether it made sense or not. Now at this point you might be fine. Might be the detection was fine, but it might be that you have to remove false positives essentially, or on the other hand you missed spots. So if true positives have not been detected, it's very likely a problem of the thresholding. So you might have chosen here, not necessarily the thresholding, but the segmentation method. If you use Spotiflow, if you use a BioImage.io model, if you use SpotMAX AI, those spots that are not segmented first will not be detected. There's no way to detect spots outside of the segmentation masks of the spots, so you have to change the method to a less stringent one, basically, so that they get detected. On the other hand, as we discussed last time, it could be that the size of the spots is too large. So when they're close to each other and you want to detect them as separate, but you set a spot size that is too large, two spots on the same place within the same volume are not detected. So you might have to reduce this, and you can go through this. It's pretty easy to do because you have these little compute button. We saw it last time that you can visualize those steps. What is actually very interesting and very useful to do at this stage after you have detected is to look into removing false positives. So if you have a false positive that you want to remove, this is the place to do. So the only option you have to remove false positives if you already optimized this method here. Of course, one option is to change this method to a more stringent one in this case, because we want to remove more spots. But if you don't find anything that works here, it's not everything. It's kind of the power of SpotMAX at this point to use features to remove those false positives. So with that, we can go here. And basically, the idea is that in the future, we want to automate or try to get a little bit smarter about this. But for now, the way to do this is to visualize, basically, the results and see if false positives have some pattern, basically. So here on the left, as you can see, first of all, you can choose which feature to use for the spot circles. I am just looking at detections for now, so I don't change the spot size, but you could select a feature, let's say the diameter from spot fit, and you would see different circles with different size on the spot and not the fixed size that I just set manually. And if you change that to change those properties, you can go here to edit, right click, edit points appearance. I chose an arbitrary symbol size of 6, so it doesn't have anything to do with the actual size of the spots. It's just my default that I have here, and looks enough for me. But if you have to change that, you can change here and choose another feature to show the size. So you also get an idea whether the size calculation was correct or not. So as we get kind of a summary, there are total number of 10 spots in the image, and number of spots per segmented object. I think that you have to go exactly if you hover onto a spot, it updates the number of segmented spots per image, per cell. So here I go into this one. This cell has 2 spots. This cell has 1 spot, and so forth. When you hover onto a spot, you start seeing their properties. So for example, if I go here, I get the spot ID, which is just a number the ID got, the spot got, a Z and the X coordinate, the Y coordinate, and the Z coordinate. And this is where you can choose basically which feature to visualize. So here you have to choose, you have to think about which features might describe your false positives. So the idea would be to find a threshold that separates false positives from true positives. And one of the most used one is, as we talked the last time, is the effect size. So we can go here, go into the effect size versus background, and usually I recommend using the glass, but feel free to explore all other features and maybe find the one that separates them best. We press here, we want to see the effect size versus background glass. You can choose to view as many as you want, because as you remember, you can use as many features as you want to separate, to filter out and remove false positives. But now let's say we want to use effect size, and when you hover with your mouse onto a spot, you see the effect size changing. So here is 0.07, here is 0.09. This one that is really bright, as you can see, has a much higher effect size. And the effect size versus the background is a measure of the signal to noise ratio of the spot. The brighter the spot sitting on a darker background, the higher the effect size. So in this case, we have 0.08, 0.07, 0.09. And let's say that these are false positives. By setting an effect size filter at, I don't know, 0.1 would be enough to keep this one, but remove this one. So let's actually go to see the other ones. This is a 0.7. This is a 9, it's the brightest. This is a 0.12. And this is a 0.19. This one is 0.1 and 0.7. So you could see that if these are 3 false positives, they will be easily filtered out with an effect size of 0.1, because 0.1 is above these 3, but it's below all other spots. So I could go back into the analysis, set the effect size to 0.1, and run the analysis again. I know this sounds a little bit of a hand wavy method, but trust me, it's probably very it's actually very good and recommended to spend some time getting an idea of visualizing your data, how it looks, and so forth. Because even if you would go a machine learning method, before machine learning, there is always a step of data exploration where you go and spend as much time as possible with your data and trying to understand patterns and see if you can spot stuff, because any algorithm would not be smarter than you spending some time with your data anyway. So that's it basically. So it covers most of the basics for SpotMAX. You can run the analysis, you can view the results, see what kind of features works best. And in the next videos, we are going to talk about maybe tuning the parameters in a little bit of a smarter way. But I think that with this, it basically gets you all the way to really good results. If for some reason nothing works, don't hesitate to contact us, and we can see together whether there was some easy thing that can be done, or the worst case scenario, your specific data might require some additional features development that we are very open to do. Most of these features that you see here have been developed specifically for some data sets, so there's absolutely no problem about that. We can discuss whether, I don't know, new features, new ideas, absolutely no problem. The easiest ways to contact us is by opening an issue on your GitHub page. If you don't want to be public about it, you can send me an email, and we also have a Slack workspace. If you contact me on email, I can send you the link. That's probably the easiest way to talk directly to me and discuss your specific image analysis problem. So with that, this is everything. So until next time, bye.